Okay, another antiderivative problem where we're going to use the chain offsetting rule and take that into account. So let's take a look at this. We're asked to find the antiderivative of e to the radical x over radical x. Now, let's think about this for a second. Is one the derivative of the other? And if I was to look at e to the radical x, well, the derivative of e to the radical x is obviously e to the radical x times the derivative of this. Well, the derivative of that would be 1 over 2 times radical x on the denominator. So, well, this looks familiar. I've got radical x on the denominator. I've got radical x on the denominator. So that's the natural order how that derivative would manifest itself. So I don't need to offset that. What I do need to offset, though, is this 2. So I'm going to need to multiply by 2 and take the antiderivative of this. Okay, so on the outside of my derivative, the outside of my antiderivative, I'm going to multiply by 2, and I'm going to take the antiderivative of e to the radical x. Well, the antiderivative of e to the radical x is just e to the radical x. I've already taken care of offsetting everything with the 2, and this will naturally appear. This will naturally happen. So all I need to do is write the plus c, and I've got my answer, which happens to be A. Tricky problem, for sure, and something that we certainly need to understand the derivative and antiderivative rules of e to the radical x, and also understand the derivative rules of a radical. Identifying that quickly I was able to signify in my mind, oh, I know that when I take the derivative of a square root, that I get a square root on the denominator, and that flashed in my mind, oh, that's important, that's important. Okay, I'll see you guys back for problem 8.